So in this video, we're going to do an example that involves a double inequality, like you see here in problem number 2. This is a shorthand notation, but what it really represents is the solution to these two inequalities put together. So like -4 is less than 2x plus 3, and 2x plus 3 is less than or equal to 2. So we call these compound inequalities, and normally we would isolate x for both of these and then find where the solutions overlap. The nice part about double inequalities is that we can solve them by isolating the x in the middle here. So we don't have to do this work twice here. We can actually just do all the work at the same time. So let me rewrite our double inequality here. And again, the goal is that we're going to want this x to be alone here in the middle of the compound inequality. So that means we first are going to have to move the 3. Okay? And I know you know that means we're going to subtract 3. But this time we're going to subtract 3 from all 3 parts of the inequality, like that. So here we then get -7 is less than 2x, which is less than or equal to -1. Okay? And again, our goal is to get x by itself, so our next step then it would be to divide by 2, and we're going to divide everything by 2. And as you know, with an inequality, when you divide by a positive number, it will not affect that symbol. Okay? So this looks good. So we have -7/2 is less than x, which is less than or equal to -1/2. So what's nice about having the inequality written like this, notice how we have the smaller number, -7/2 here, -3.5, right? And then -1/2 is the larger number here, is that our graph is going to match that. So here we have a boundary point. -7/2 is -3.5, so it'd be right about there if we were going to graph this. And we would be graphing that with an open dot because there's no equal sign, right? So we don't include that -7/2 as part of the solution to this inequality. Okay? Over here, our other boundary point is here at -1/2, and now there's an equal sign there. So at -1/2, which is right here, we're going to put a closed dot to indicate that we do include the -1/2. And then for the compound inequality like this, the solution to the inequality is going to be any of the numbers that are here in between these two boundary points. And so notice that our inequality kind of matches the graph. Okay, now we do want our answer in interval notation, so you just want to remind you that when you have an open dot, then you're going to use a parenthesis. So parentheses -7/2, comma, and then over here our 1/2, since you have a closed dot, we use a bracket for that to indicate that it's part of the solution. And again, notice again how these match, the order that these are in will match your interval notation, your graph, and your double inequality. Okay, all right, let's do one more example with these double inequalities. So take a look at number 3. Okay, and again, our goal is to isolate y in the middle of these 3 parts, right? So we're going to, of course, subtract the 9 first, right? And again, you want to do that to all 3 parts. So there's -9 here, but then you have to subtract 9 from this one, from the 41, and you have to subtract the 9 from the 25. Okay, so here we get 16 is less than or equal to -8y. This, of course, gives us 0, is less than 32. 41 minus 9. Okay, so that's looking good. Now, our goal is to get that y by itself. So this -8, we need to divide that out, don't we? And we're going to do that all 3 of these numbers, right? But what is the one thing we always remember when we divide or multiply all the sides of an inequality by a negative? You have to switch, you have to flip the direction of the inequality symbol. So when you're going to notice that in my next step, I'm going to do the division, right? So I'm going to take 16 divided by -8, flip this symbol, and then I have -8y divided by -8, flip the symbol, and we have 32 divided by negative 8. So again, these happen at the same step. Okay, now simplifying, we get negative 2 is greater than or equal to y, which is greater than negative 4. Now, the way that this is written, notice that our smaller number, negative 4, is on the right, and our larger boundary point is on the left. Personally, I don't like that because then it doesn't match my inequality, doesn't match my graph. So we can rewrite this inequality by just switching out the places. Okay, so notice what I did. I put the negative 4 here on the left and the negative 2 on the right, but then I had to switch the symbols around so that they, we have an equivalent inequality. So here we are, boundary point at negative 4. That's an open circle because we are not going to include that, right? We have no equal sign here. And then boundary point at negative 2 is going to be a closed circle there. And y is all the numbers in between, right? The solution is all the numbers in between negative 4 and negative 2. And our interval notation then will be negative 4 with a parenthesis to not be included to negative 2 with a bracket.